Hi students, this is K.M. Varaprasad. Today we are discussing the database management system. In that database management system, we are in the unit 3. In that, now we are in lesson 4 or lecture 4. Now coming to this one, already in the last classes we discussed about what types of data we are using, how we are storing the data into this one, etc. Now this is about the relational database design, how we are designing this one. Already in the last classes we discussed about entity relationship model, but here we are discussing relational database design, how we are designing the relational database or something. Now coming to this. Database tables and normalization. This is the concept, very important one. By using the normalization technique, we are converting all the entity sets or relationships into the proper form. The database tables are basic building blocks in the database design process. Now coming to this one, the database design process explored ERM and it yields good table structure. Now here it is possible to create a poor table structure even in a good database design. Coming to this one, here we have a question here. How do you recognize a poor table structure and how do you produce a good table structure? Normally, a very good design also sometimes produces a poor tables. Here the recognition of poor table structure and a very good table structure will provide the very good database design. Now in that one, we are using different types of concepts like normalization and different type of some anomalies we are producing based on that anomalies, and then some set of things we are creating the very good table structures. The answer for both questions here is it is normalization, involves normalization. Normalization is a set of rules used to decompose the data into two or more subtables to minimize the redundancy and maintains consistency of the data. Now, these are the very key terms, that is consistency and then minimizing the redundancy and improving the consistency. Now, these are the very important things. By using the normalization is the powerful tool or powerful technique which is especially used to decompose the different tables or different entity sets which are available in this one into the meaningful form, or by using that meaningful form we can easily remove the redundancy and maintains the consistency. Normalization works through a series of stages called normal forms. Here we are using different normal forms for the purpose of normalization. Every stage, initially we started from first normal form. In that one, after one by one, we are reducing all the things and maintaining different types of concepts are there. Using those concepts, we are working on that. Finally, we will get the very good tables, which contains less number of attributes, and then those can maintain the redundancy, that means reduce the redundancy and maintain the consistency. Here, normal form is a state of relation that results from applying simple rules regarding functional dependencies to that relation. Some set of mathematical rules are available and mathematical techniques are available. Those are called as functional dependencies. Here we are using some mathematical technique that is functional dependency. Using that functional dependency, we are creating the dependencies or something. We are applying some different types of rules or protocols. By using that protocols, we are creating some set of tables. Now here the normal form is a state of relation that results from the applying some set of rules. The normalization concept is defined by E.F. Code in the year 1975. E.F. Code is the scientist which defined the concept of normalization in the year of 1975. Now, E.F. Code defines the first three normal forms called 1NF, 2NF, and then 3NF. The revised version of the 3NF called BCNF, that is Boise Code normal form. It is defined. It is also defined by E.F. Code. Fagin defined, the scientist name called Fagin defined 4NF and 5NF for multi-dimensional databases. Nowadays we are using multi-dimensional databases. For that purpose, we are using, and the scientist developed, that is called as Fagin. The scientist named Fagin developed fourth normal form as well as and fifth normal form. The 5NF is also called as PJNF, that is Project Join Normal Form. Project Join Normal Form. For most purposes in business databases, 3NF is a high as you need to go in normalization process. Now, 3NF is sufficient to represent a maximum number of business databases. This is more than enough for practicing all the things. Here comes to the first normal form. A relation is in first normal form. A relation is in first normal form if and only if domain of each attribute contains atomic value and no two rows of data must contain repeating groups of information. Now this is about the identify primary key. Now this is about the repeating groups are eliminated by using the first normal form. Especially the first normal form is used to eliminate the repeating groups. The value of each attribute should be atomic and identify the primary key. That is the thing. Now comes to the second normal form. The table is said to be in second normal form. It holds the following conditions. Some set of conditions we are taking here. Table is in the first normal form. It should be in the first normal form. And then the second technique we are applying, no partial dependencies. Now here we discuss what are the partial dependencies here. Now comes to the third normal form. The third normal form, the table is said to be in the third normal form. It holds the following conditions. It should be in the second normal form. If it is in the second normal form means it maintains all the discussed thing that is in the first normal form and no partial dependencies. Now, if the table is in the third normal form means it should be in the second normal form first and then comes to the no transitive dependencies. Here in the second normal form and then no table, that means no transitive dependencies. Now comes to the Boise Code normal form. The table is said to be in BCNF. It holds the following conditions. Now some conditions it can take. The table is in the third normal form. Every determinant should be a candidate key. Here some determinants we are taking, that those determinants should be candidate keys, should be a candidate key. Now next one comes to the fourth normal form. The table is said to be in fourth normal form. It holds the following conditions. Some set of conditions it should be taken. Now coming to the Tables in BCNF, the table should be in the Boise code normal form, and then no multi-value dependencies. No multi-value dependencies. No, if it is in a, if you are going to make it as a fourth normal form table, you should maintain the prerequisites like table should be in the BCNF first, and then we are applying one technique that is called no multi-value dependencies. Multi-value dependencies are also not available in this one. It comes to the fifth normal form. The table is said to be in fifth normal form. It holds the following conditions. Table is in the fourth normal form. It should be in the fourth normal form. And then it should not contain any joint dependencies, and joining should be lossless. Now, here different types of joins which are available, lossless and lossy joins are there. The join should be lossless only, and then it should be in the fourth normal form. For that purpose only, we are going to prepare the table which is available in the fifth normal form. Now coming to the what is actually the functional dependency. What is the functional dependency? Is also very important concept. Functional dependencies. The attribute B is functionally dependent on A if each value in column A determines one and only one value in column B. Now if we are taking two columns here, A and B, the attribute B is functionally dependent on A. Now B is dependent on A means if each value in column A, determines one and only one value in column B. Now for that purpose, this concept is called as the functional dependency. Now symbolically represented as A arrow mark B. Here A is determinant and B is dependent because A determines B. Now this is about the functional dependency. It is a very useful and very important concept. Using these functional dependencies, we are maintaining or we are creating different types of normal forms, starting from the second normal form and then so on. Now coming to the keys here, this is also already we discussed about the what types of keys we are using, and here also the keys plays the major role. Different types of keys are available, especially those play the major role here. Now coming to the first one is super key. It is a key that identifies a row uniquely. Here, what is the main purpose of the key here is some set of rows are there, many number of rows are there. Every row is unique. Now, for the purpose of identifying the row uniquely, we are using the super key concept here. Now, coming to the candidate key. Here, many number of keys are there. In that one, here one table is having different types of super keys. In those super keys, the minimal super, that means minimal super key is considered as a candidate key. Now, for the purpose of implementation and for the purpose of things, we are considering minimum only, minimum accurate we are considering. For considering minimum accurate, we are taking the candidate key. Now, this is about the minimal super key is called as the candidate key. Now, coming to the primary key. Choose any one of the candidate key becomes primary key. Any one candidate key becomes the primary key. Now, for example, the minimal key, no, two minimal keys are there. We can choose any one of the primary key. Now, it should be it should be used as the practical purpose, especially. Primary key is the only key we are using for the purpose of practical implementations. Now, coming to the composite key. A key may be composed of more than one attribute, such as a multi-key is known as composite key. Now it contains more than one attribute is considered in this one, that is called as the composite key. Now coming to the foreign key. A foreign key means that an attribute is one table whose values must be matched with the primary key and another table, primary key attribute of the another table. Now this is about the foreign key. It is also very important to provide the relationships. The relationships are provided by using these types of foreign key concept. Now this is about the concepts we discussed here. Now here designing, for the purpose of designing, normalization plays the major role. We are having 6 different types of normal forms: 1NF, 2NF, 3NF and BCNF and 4NF and then 5th NF, that is 5NF. Now these are the things we discussed in this lesson or in this video. Thank you.